principal goal? To drill down deep in search of microorganisms.
What is new with ExoMars, with the rover in particular, is what we call the mobility. Mobility not only horizontal, but also vertical. And this is a peculiar thing that we have on board the ExoMars mission. So we will be able to sample material from below the surface. That is quite important to understand if there is any sign of past life activity on Mars.
We will be looking for the first time in the third dimension being depth. And we think that is where we have the highest chance of making an interesting discovery regarding the presence of organic molecules in Mars.
It's a whole planet out there with a complicated history. That history is a story that's stored in the rocks, and our job is to figure out that story and what that story of that planet tells us about this planet that we live on.
So where Curiosity takes rocks and grinds them up into powder and looks at their bulk constituents, what this mission would need to do is be able to look in a microscopic level and examine the rocks for these very tiny and detailed messages that they would be sending to us about the past life that could have lived there.
This that I'm holding up here is a classic biosignature from the Earth. It's a fossil. We're not actually expecting to see a fossil of shells or other components, but what we want to be able to see are, with this instrumentation, are the fine scale layering that one might see in a rock, in which we can see dark and light toned layers. And those dark and light toned layers are telling a story.
When will NASA send astronauts to Mars?
4, 3, 2, 1. And liftoff at dawn. The dawn of Orion and a new era of American space exploration.